Well, I've been talking about structural optimization before. But I want to change the scale a bit, to show you that optimizations with the proper combination of CAD and static analysis software can be very effective on a smaller scale too. In order for me to explain the possibilities without going into details, I will demonstrate what we can do on a simple example. Imagine that you have to design a very simple table. You set a tabletop, you put 4 legs, you need to set the material, you set the thickness of the top as well as the cross-section of the table legs. Now you set some loads like gravity, self-weight, and some additional load. And you have to define some boundary conditions like bearing points. And now we can decide on our variables. Since this is just a simple example, let's say each table leg can wander around a certain area. Now what is left to do is to set the goal of our optimization. Some standard mechanical goals are stability, optimal usage of material, uniform stress distribution. Let's say we want to minimize the total amount of stress in all elements. As an optimization technique, we will use our favorite, genetic algorithms. Let us slow down and zoom in to see what is happening here. For every solution, a new geometry is generated and all static analysis settings are updated. You see how we automatically mesh the surface elements and how the connections are recognized and included into the final finite element model? Different solutions are generated, their fitness is calculated, and through a simulated process of evolution, our optimization converges easily and gives us the fittest individual. In this very simple example, on a pretty average PC, we can generate and statically analyze approximately 10 solutions per second. That is more than 35,000 solutions per hour. Just imagine the numbers on some powerful supercomputer. And now let's start the creative process, asking questions. What happens if I let this point move? And another one, third, fourth, fifth, sixth. Okay, this table is boring. What if I want to design a lamp? Double curved surfaces are no problem. Let us try to do a chair. At this point, it is worth mentioning that you don't have to calculate the structure statically. You can have geometrical optimization as well. Look for a golden ratio. Search for a particular proportion of lengths, surfaces or volumes. Compare element sizes. Even better, you can have multiple objectives at once, statical and geometrical. Try designing a shelf. You can simply start somewhere and expand. I want my TV here, I want my books here. I want this part to be at least 1 meter long, but not longer than 1.5 meters. Wait, I want this flat. No, I want it curved. I want the total volume of the shelves to be exactly 1 cubic meter. I want to use maximum 3 square meters of wood. So you go on and ask as many questions as you like and observe how the answers produce themselves in front of your eyes in a matter of seconds. Get the idea? We can vary anything. We can vary the geometry, but we can also vary the cross sections, the thickness, we can vary the material, we can vary any geometrical or statical property of our object. These examples are pretty straightforward and very simple, so before we go on with some very cool and complex optimizations, I will let you think about it. I will let you ask questions. I will let you imagine. Get back to us.